should say real number system in blush bear right there. But it doesn't. You just have a bunch of dots, right? Super lame. That's what happens when you get other people to do the work for you. Braille? Morse code? Oh, that would be wicked if I had a Morse code font. Oh, I'm totally going to look that up. A Morse code font would be so funny. It would be like all the way across the page, dash, dash, dot, dash. Wicked. It would take up like half the page. You have one job today. When I say go and you're doing work, you say, Myers, see if you can get a Morse code font. Okay. No, you won't go to the right font site. I have a very specific font site that I like to use because I'm super font nerdy. Nerdy. Font nerdy. F-O-N-nerdy-T. Fonerdite. There we go. Yeah. All right. You guys need to know this stuff mostly because it affects how you will present work in higher grades. That's why I'm doing it right now, because it's not really that important with what we do here, but it is important in how you present your work in higher grades. So we'll talk about this. All of you already know it, especially if you're in my class. The natural numbers are very simply the numbers. If I say, class, let's count together. When I hit the desk, we're all going to start counting. Everybody ready? Ready, set, go. Great. You all started with 1. Is 1 the first number? No. Of course not. So the natural numbers are our counting numbers. And they, of course, go from 0 up to what? Infinity. Now, can we actually count to infinity? No, infinity is a concept. It's not a thing. Everybody with me? All right. Our counting numbers. Now, our whole numbers are our naturals plus 0. So actually, this first one should have said 1 to infinity. And then the second one is 0 to infinity. Now, what is missing? If we keep counting, let's count 1, 2, 3. What are we skipping? Everything in between. How many numbers fit between 1 and 2? Infinity, right? So, we have to be mindful of that. Hey, Rihanna, you're back. Integers are the naturals plus the negatives. So they go negative infinity up to positive infinity. And there we must draw a line. Because these guys share some properties. These are no fractions. And if there's no fractions, what are there also automatically none of? No decimals. So I said this was important in how you present your work. What I mean by that is if you are collecting data which doesn't have decimals, for example, you are counting people, 0.7 of a person cannot walk through the door, can they? So later on, you will see data presented to you, and you will see things, and this will maybe remind some of you in your minds from when we were talking about sets in grade 10. You remember seeing things like this. X is a set of real numbers. Or X is a set of integers. When you see that in future math, you know that you are not allowed decimals and fractions. Okay? There are proper abbreviations for all of these, but I cannot remember them right now. It is not NWI. I think W and I are okay. I can't remember what N is. All the numbers are R. I'll get back to you on it, but it's not really important. You just need to know, if you see it written, that these are what we call restrictions. and they restrict which number system you are using in that particular instance. Everybody good? Okay. For our purposes, it will almost always be real numbers. So all the decimals, all the fractions. All right? It also comes back to discrete and continuous data, which we have talked about a lot last year as well. Now we're into something new. The rational numbers are every number that can be expressed as x over y, except there's some rules. You son of a y iota. X and y must be integers, and y cannot equal 0. So, just to make sure we're all on the same page, is that a rational number?
Yes.
Excellent. Is 0.4 a rational number? Why? But 0.4 isn't an integer. So how do I make this look like that? Yeah, this is 4/10, right? And that's okay. Everybody with me? Okay, what about this? 1.23 over 1.47. Is that rational? Does it appear to be rational right now? No, because 1.23 and 1.47 are not integers, are they? But is 123 over 147? Yes. And will these two give me the same decimal? Yes. So that is rational. Is everybody good? Okay. The other thing about these, the other thing that you people like to remember is it is also ending or repeating decimals. I don't like to talk about decimals because I don't like decimals. Decimals are kind of like asking your mom to go to the movies when you're 25. Decimals they're wussy. Okay? Fractions are where it's at because fractions are exact. Decimals are wussy. Everybody cool with that? I know I'm body shaming decimals, but I don't care because they're wussy. You don't know that. Do you?
Do you know that they do have feelings?
I tend to err on the side of caution.
I like to play on the wild side.
You go, guy. Now, obviously, irrational numbers are ones that is everything else. And of course, the most famous one is pi, because even though pi is found by taking a circumference and dividing it by a diameter, so it looks rational, it isn't. It is a decimal that goes on forever. There's a computer in Boston that has been working on decimals of pi. It's up to trillions of decimals. It's not going to repeat. I know that you should never say never, but it's not going to repeat. Another famous one is E, which none of you use. It is 2.78, blah, 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 forever and ever and ever and ever and ever. It has use in a lot of financial applications, and it also helps in physics again. But more importantly, for our intents and purposes, it's roots. It's roots that don't end up rational. So, for example, the root of 2 is irrational. When you push square root 2 on your calculator and you get 1.414728, blah, 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 the only reason that stops, of course, is because your calculator screen ends. The decimal would go on for infinity. So this is where our irrational numbers comes into play for grade 11. That's what we care about. The square or the cube or the fourth or the fifth or the eighth root of a number that isn't rational. Everybody cool? Sweet. And all of you know that from grade 10. So now take 5 seconds, put those into the right categories. You may remember seeing this in your grade 10 book. No cheating getting a calculator, Anderson. Remember, if it fits in natural, it automatically fits in, or other way around. If it fits in natural, it's automatically a whole and an integer. Delicioso. I got to the water fountain before lunchtime when all the kids take all the cold water out of it. So I got nice cold water today. Sometimes the water out of that thing is like pee warm. It's gross. Not that I would know how warm pee is from drinking it. I would know how warm pee is because your body is 37 degrees. So when the pee comes out of it, it's 37 degrees.
Celsius?
Yeah.
Fahrenheit.
Celsius. 37 degrees Fahrenheit? That's like 1 degree. You would move like this. If you open the fridge, you would freeze solid. Of course it's Celsius. And we live in Canada. But in Fahrenheit, I know you're a big American fan.
I'm American now.
Are you really?
Yeah.
Oh, sorry. 98.6 degrees Fahrenheit. A useful measurement. Fahrenheit. How hot is it out there? It's 120. What the hell does that mean? Nothing. When does your water freeze? 32? Whatever. Shut up. Dumbest measurement system in the world.
Worse than imperial?
It is imperial.
Oh,
Fahrenheit is imperial. That's why it's dumb. Because water boils at 212 and freezes at 32. Those are good, smart numbers. That makes good sense. Hey, Hallie. Yeah, go to the bathroom. All right. What's the first one? Irrational. Because, of course, there is no cubed root of 14. What's the square root of 25? 5. So it is natural, which means it's automatically everything else. What about that? It's rational. Why? Because it ends. As a fraction, of course, it is 5,319,754 over 10 million. Right? Of course it is. What about that one? Of course you were supposed to keep going. It goes to G. What happens when you were in kindergarten and had to do the alphabet, Josh? And let's sing the alphabet. A, B, C. And another one, and another one, and another one. There used to be a very mean joke about Irish people. Because back, people used to tell ethnic-based jokes. Nobody does that anymore, but people used to. And Irish people are widely hailed by the world to be stupid. I don't know why. Hey, My mom's mom was born in Ireland. I'm with you, man. I don't get why we get it. Right? I don't understand it. Ireland saved the world as far as I'm concerned. But you look back in the history of Canada, Montreal in the 1800s, signs on the wall, help wanted, no Irish need apply. The Irish were the worst treated of the European folks in the world. They were treated as badly as every other minority group. Anyways, how do Irish people count? 1 lassie, 2 lassie, another lassie, another lassie, another lassie, because they can't count past 2. It's a horrible joke, but people told it all the time.
Why?
I had a teacher tell that joke to me.
That wasn't even that funny.
I know it's not that funny because it's mean. But it's okay. But it's not. Teacher told me that joke in 1981. 1981. Yeah, I was alive in 1981. I was in grade.
12?
Shut up! I was in grade 1. Grade 1. Whatever, Anderson. What's the answer? Jack.
NWI.
It is natural because, of course, it is 16. This is natural. What's this? It's tricky. It's not irrational either. No, how can you have a square root of a negative number? Yeah, it's not irrational. This is what we call an imaginary number. And you think I'm joking like it's Sesame Street. It's not. They exist. Well, they don't really exist. You won't need to worry about imaginary numbers until... How many of you are planning to go to university? How many of you are planning to take Calculus 100 at university? How many of you are planning to do any kind of science degree? So you won't have to worry, and you're in grade 11 now, right? You're graduating grade 11 in 2019, so you graduate grade 12 in 2020. You're going to go to university right after high school? So you're going to graduate first year in 2021. So you don't have to worry about imaginary numbers until at the earliest September 2021. But suffice to say, imaginary numbers are square roots of negatives. And they have applications in, guess what? Physics. What's this one? This is tricky. What? You say it's rational. Why? It looks like it repeats, but what if the 87th decimal is a 7? There's no line. If that was there, it's rational. But this, you can only say it appears rational. That's why I put those two at the end, down where Jashin can't do the alphabet anymore. Man, sitting in the front sucks.
Jashin's just getting burned on YouTube now.
No, but Jashin has the microphone right here. He can say anything he wants about me. These people are heard quite regularly. If you watch last semester, a girl sat there, and all the class was like, yeah, it was awesome that she sat there because she asked questions all the time. And everyone else was scared to ask questions. As you all know, for some strange reason, those of you that have not been in my class, apparently people are scared to ask questions in my class. I don't know why. I answer every single question nicely. I don't get it. Unless it's a silly question like, I should have done D, E, and F. Anyways, she would ask questions all the time. And the class was like, yeah, it was so good that she sat there because she would ask the questions I wanted to ask. And then you could hear them on the microphone. And then I would know that that was when my question was being asked. It was very useful. Go. I'm going to give you 30 seconds to do this, then we're going to mark it. Ready, set, go. Done. Time up. How'd you do? You don't know because we haven't marked it. Where are the ticks? For 3/4, where are the ticks? There can only be one. Rational. Everybody who ticked rational, give yourself 1 point. Well done. What about 10? Natural. Whole. Integer. Is it rational? Of course it is. It's 10 over 1. So that's 4 points. If you have anything blank, you lose a point. The winner is getting gummy bears. Oh, now everybody want 10 more seconds? Now that there's a prize on the line?
I'm giving them a second chance.
It's only the second day, Jack.
This isn't hard.
True dat. 10 more seconds. But wait. And go. Time is up. It's a gong. It's awesome. Yeah. That's what I used to wake up in the morning. Except I sleep so badly that as soon as the phone vibrates, because it vibrates before it does bong, that's what wakes me. It's frustrating. I used to have the Dukes of Hazzard jumping over a bridge. And I went, yeah! But my wife got mad at me because she said it was too abrupt. So I got her a gong. I feel that sounds more. Oh. She's a wuss. 1, 2, 3, 4. Negative. Integer. Rational. 1.5. Rational. 215. Rational. Irrational. Where does 0 fit? It is whole. It is an integer. Is 0 rational? Yes, of course it is. Oh, wait. I was ticking out on pi. Pi is irrational. And then 0 is everything but natural. 0.5155. Irrational, we have to say. Root of 3. What's the root of 3? Irrational. 8.1. Rational. Negative 153. Integer and rational. 3.14. Just rational. And 23 over 8. Just rational. If you have all those ticks, you're getting 4, 2, 1, 1, 1, 4, 1, 1, 1, 2, 1, 1, 2, 4, 6, 10, 11, 12, 13, 14, 16, and 8 is 24, 25. You have a possibility of 25, but any blanks? If I have a tick that you don't, you lose one. If you have a tick in the wrong spot, you lose one. Who wins? What do you got? Shut up your face. Really? Anybody else? Anybody else get 25 out of 25? No? There's a new treat this year, Liam. You can bank your gummy bears in the First Abbey Senior Bank of Gummy Bears and earn a very impressive interest rate. In December, some of my grade 10s won some gummy bears, and they put one gummy bear in the bank. And already by the end of January, they are now owed 5 gummy bears. It is a very competitive interest rate. Would you like to invest your gummy bears, or would you like to have instant gratification, head over to the freezer and get your gummy bear now? You will bank your gummy bear? Interesting. I have a spreadsheet for this. That's how nerdy I am. Yes, Van Damage, I made a spreadsheet. I used to have it on the board, but then people were messing with it. They were hacking into my system, and they were changing the numbers. So now I got it. Now I got a spreadsheet.
That's what Leighton did all of grade 9.
Yes. So Liam, 1.
What is the interest rate on the gummy bear?
The interest rate is, I believe I give 5% per week. Or maybe I give 5% per day. I can't remember. I think it might be 5% per day. Compounded weekly. That's what it is. I can't remember. You'll notice we do a finance unit at the end of the year. So yes, you can do very well by the gummy bear with shrewd investments. True or false? If it's false, make it true. Go. I saw my new favorite shirt today, Jack. A NASA shirt, but at the bottom it says, "Give me space." I would buy it, but, I only wear shirts and ties to school. But if I wore that, and then that kid wore that shirt that day, it would be awkward. It's like wearing the same dress when you show up. Oh, wearing the same suit when you show up. See what I did there? That was funny. You guys are a tough room, man. Afternoons are going to be difficult in here, I think. Because I know I'm damn funny. Looks aren't everything, but I know I'm damn funny. Who's doing the first one for me? Are all natural numbers integers? True. More people should have volunteered for that one. That was the easy one. B. Is that true?
No.
So what's your counter example? How do you make it true?
All integers are either negative infinity or 2 infinity.
So is 7 in there?
Yes.
Is 7 a rational number? Okay. Is negative 7 in there? Is negative 7 a rational number? Okay. Is negative 812 in there? Is that a rational number? So if it happens once in math, how often does it happen? Always. So are all integers rational numbers? Ooh, you're lucky you got that gummy bear into the bank. All whole numbers are natural numbers. False. How would you make that true? Pardon? You just reverse it. All natural numbers are whole numbers. Yay! You guys are brilliant! Brilliant! What's the next page in your book?
Braille and then 7 to 3.
Is it that?
Yes.
Excellent! Now, remember how in grade 10, I warned all of you that were in my grade 10 class, said you all think you can kick exponents' asses, and then you wrote that test and it was your worst test of the year?
Yes.
Everybody remember that? Huh?
Mine was trigonometry.
Yeah, but class average-wise. Yeah. And then at the end of the year, I gave you a final with some exponent questions on it. Guess what the worst performed part of the finals were? The exponent questions. I know, right? How important are exponents? Pretty damn important. So, you also recognize this from your grade 10 book. We're going to go over exponents again because people still don't get them. What's the base? 7. What's the exponent? 3. What's the power? Yeah. The power is the whole thing. 7 to the third. And we read it as 7 to the third. But it also gets a special name, 7 cubed. What's the other special name? 7 squared. Are there any other ones? No, there's not. Everything after that, we use the actual number. Right? You already know this. 7 means 7 times 7 times 7.
So it would be like 7 quadruple?
No, we don't do it. Because there's only 3 dimensions in our regular life. We say cubed because a cube has 3 dimensions. And if that's 7 squared, and that's 7 cubed. You guys have all filled this chart in before for me. Well, everybody but like 4 of you have. So everybody's going to fill it in again. The part you're going to be bothered by is where I make you do this part in the middle. Because you're all like, I know how to do it. And then, of course, I give you difficult ones and you screw it up. It's because you don't spend your time to do this part. Go ahead. Fill it in. Make sure you know what you're doing. Because if you actually understand this chart, then all exponents are easy. Thanks, Liam. So he lost his take backsies, so I'm taking them back again. And then I'm giving them back, so we're even. I think Liam did that on purpose.
No, I just realized.
Mm-hmm. Were you in Louis' class last year?
Yeah.
Louis continued in grade 11 to remind me constantly, all the time. Louis was on top of it, man. If this pen touched the screen, are you recording? And then he stopped. And then at the end of the year when we were doing review, I did like 5 pages and Louis didn't tell me. I know, right? What's the answer? X to the 5th, which is wonderful, but you really need to remember why. Because when we stack all 7 of these in one question, you guys screw it up. Because that is x times x times x times x times x. There's 5 x's, x to the 5th. You know this already, and yet it is problematic every year. X to the 3rd over x. That is x to the what? 2. Why? Because it is x times x times x over x. What do you get to do there? Cancel them out, because x divided by x is 1. So that would be x times 1. We would never write times 1, so it's x times x, so it's x squared. Raising an exponent to an exponent. This messes you guys up. If I show you this, oops, I want to do these ones purple. If I show you this, x cubed squared, what's the answer? X to the 6th. Then I say y, and all of you go, duh, Myers, because it's x cubed times x cubed. So what? Well, duh, that's xxx times xxx, which is x to the 6th. All of you can do that. You can all do it in your head. It makes no problem for you. Until I do this. 2x cubed squared. And now, half of you are going to tell me this answer is 2x to the 6th. Is it? No, of course it isn't. It's 4x to the 6th. Half of you, at least, are going to make that mistake on your tests, which doesn't matter in math class, because it's not going to hurt anybody, is it? But when you do the math wrong, when it does matter, there's trouble. So watch out for that. Remember, this whole thing is a base. Fraction base with an exponent. X over y squared. What is that? X squared over y squared. And I'm not even going to do anything in orange for that because I believe you. X to the 0 is what? No. 1. Why? Because x cubed over x cubed would be xxx over xxx. Same thing on top, same thing on the bottom. It's 1, correct? But the shortcut here is we do x to the 3 minus 3, which equals 0, right? So if x to the 3 minus 3 equals x to the 0, and x cubed over x cubed equals 1, then these two must be the same. right? Now, here's the next problem a lot of you will make. What is negative x to the 0? What is it? You can flip back a page and see, because the chart that you just filled in will give you this answer. Negative 1. What is negative x to the 0? What is it, Justin? Positive 1. Why? Why is this one negative and this one positive?
Because for the top one, it's just doing it for the x.
Yes.
The bottom one, it's doing it for the negative x.
Yes, exactly right. And lastly, I don't know why these got reversed. Is your 6 negative exponent?
Yes.
That's stupid. 7 should be up there. So let's fix this one first. xy to the 2 is x2, y2. All right. Now, negative exponents is a problem for everybody as well. You all already know this, but I want to make sure we are in good shape. X squared over x to the 5th. What math would you do there to do the shortcut if you weren't bothering to learn what is actually happening here? What's the shortcut? That is x to the 2 minus 5, which is x to the negative 3, right? Which means I'm going to take my base of x and I'm going to multiply it by itself negatively 3 times. Is that something that is possible? No, of course not. This is an impossibility. So we can never have negative exponents. When? Never. But they have a meaning. And Liam is going to tell us what that meaning is.
You just flip it.
That's the shortcut. You flip it and make it positive. So the shortcut here is 1 over x cubed. Now, in orange, we show why that is. X squared over x to the 5th is x times x over x times x times x times x times x. Right? What do you get to do here? Cross them out. What do you get to do here? Cross them out. What's left on top? No. 1 is left on top. Because if there was a 0 up there, it would be 0 times x and x, which would be 0, wouldn't it? And then this whole thing would equal 0. There is a 1 there. 1 over x to the 3rd. Which isn't a problem until I give you this question. X over x to the negative 3 over y to the negative 4. As soon as you guys see that, you're in trouble. And I don't know why, because everybody understands the top one. Everybody gets this, but when I give that question, they're in trouble. If this wasn't there, what would the answer be? The x would move down there and become positive. Well, then obviously what must happen to this? Goes up there and becomes positive. But remember, negative exponents never allowed. What about negative bases? They're okay. Would you do something with this? No. Would you do something with this? Yes, because now that's part of a negative exponent, a negative power. Everybody good? Great. I'm going to shut up. You are going to work on page 5 and 6. And I am going to come around and ask you to flip very quickly to your page 1. Was it 1 in your books? So I can write down what the number questions are I need to do. And then I am going to update the International Bank of Gummy Bears. Go. You can move around. You can work with each other. I do not care. I am also going to be attempting, well, like I say, names are easy. Isabel, Joret, and David. Everybody else I know. Yes, you can. Jack, I'm flipping in your book.
I already flipped it there for you.
Oh, look at you. Thanks. Close on its heels. Oh, 14 ties it up. Oh, 14 takes the lead. 14, he's starting to pull away. Cool, but 13. 14 has a 2 lead. You know why? You know why 7, 8, 9? Because you're supposed to eat 3 square a day. Yeah! Allie? 14. 14's a big winner. With 16. What was 14? Well, the linear graphing a linear system. Is it the fact that it's a system, or you don't remember how to graph lines, everyone? Okay. All right.
You're still recording, by the way.
Oh.
I was going to say some stuff.
You could have.